What's up, Certheads? Welcome back to the channel where we break down everything SAP on Azure, one step at a time. This is number 9 in our series, and today we are tackling something every SAP workload needs to thrive on in cloud: storage. We are breaking down everything you need to know: Azure storage types, Azure files, VM disks, and virtual machine images. Crucial stuff to keep your SAP system running smoothly and efficiently. But that's not all. We are also kicking up our Terraform skills up a notch by adding an output file and using looping concepts in Subnets to make our code leaner and easier to read. We will also take up question and answers. Whether you're chasing that certification, you just want to level up your cloud game, this is the video you do not want to miss. Stick around till the very end. Let's master SAP on Azure together. Don't forget to like, subscribe, comment and share if you found this video helpful. Your support helps us creating awesome content for Certheads community. Make sure to hit that bell icon to stay updated on our latest videos so you never miss the beat on your journey to mastering SAP on Azure. Let's crush those certifications together. Storage is one of the core services in Azure. Storage account is the backbone of where all your data goes, whether you're storing files, managing databases, or backing up logs. So what exactly is a storage account? And what are the features of a storage account? A storage account is a secure, highly available and scalable way to store different types of data in cloud. And the best part, Azure manages everything from hardware maintenance to ensuring your data is always available. Let's have a look at the key features of the storage account. First up, durability and high availability. Your data is built to last and can survive any hiccups in cloud. Next, security. All the data that you write into a storage account is automatically encrypted. Yes, by the service itself. Sleep easy knowing your data is locked down tight. How about scalability? It's designed to be massively scalable. It can handle all type of data from your SAP workloads. Whether it's 1 gig, 1 petabyte, Azure's got you covered. Oh, and it's fully managed. That means Azure takes care of all the nitty-gritty stuff like hardware maintenance and updates, and even handling critical issues. You can focus on the workloads while Azure does the heavy lifting. And finally, accessibility. When your data is accessible from anywhere around the world over HTTP or HTTPS. And whether you are in New York, in New Delhi, your data is just a click away. Now let's understand what kind of data we can store in the storage account. First up, we have Azure Blobs. This is perfect for storing text and binary data, and it's also great for big data analytics, making it super versatile. Now if you're working with big data or analytics, you're gonna love Azure Data Lake Storage. It's actually built on top of blob storage but optimized for structured and unstructured data. Data Lake makes it super easy to run big data analytics using tools like Apache Spark, and you can also use Hadoop. Without worrying about how you store and organize your data, is designed to handle huge data sets like gigabytes or petabytes, and is ideal for advanced data analytics. Next, we have got Azure File Shares. Now, this is all managed file share. Easy to set up and you can access it anywhere. Next, it's Azure Elastic SAN. This is fully integrated solution, simplifies deployment, scaling and management and configuration of SAN storage area networks in Azure. It's like one-step shop for all your storage needs. You need a reliable messaging between your application components. You can use Azure Queues. It's a messaging store that ensures your communication are seamless and reliable. And the applications can send messages to each other seamlessly. For structured data, we have Azure Tables. This is like a NoSQL store that offers schema-less storage and gives you the flexibility on how you manage your data. And don't forget about Azure Managed Disks. These are block-level storage volumes specifically designed for Azure VMs, perfect for performance and reliability. Alright, now that we have covered the basics of Azure storage accounts, it's time to talk about one of the coolest features for handling unstructured data, Azure Blob. Whether it's media files, logs, or even virtual machine disks, blobs are where it's at. And guess what? Blobs offer a locking mechanism that's perfect for exclusive file access, something your IaaS virtual machines absolutely need. So what are blobs? There are three main types you should know about, and each one has its own use case. First up, we have got block blobs. Now, these blobs are made up of individual blocks of data, perfect for storing large amounts of data and unstructured data. Think of it like text files, binary files, or anything you are streaming. They are by far the most popular type of blob storage in Azure. Now let's go to page blobs. These are your go-to for random access scenarios and structured data. They're optimized for things like virtual hard drives or database files. The best part? They offer superior performance for frequent read-write operations. You're dealing with virtual machines, page blobs are your best friend. Finally, there is append blob. Like block blobs, append blobs are made up of blocks. They're especially optimized for append operations. Think of it like adding a data at the end of a file. Perfect for logging data, and you're constantly writing sequentially. Now that you have got a lockdown of all three types of blobs, let's jump into a hands-on demo where we will create an Azure storage account and explore all the cool features of Azure Blob Storage. Okay, now let's head over to the Azure portal and create a resource group in which we are going to create our storage account. Okay, now the resource group is created. Let's go to the marketplace and create the storage account. We'll type storage account, click on create, give it a name, make sure it's all in small case and within 13 characters. Now our storage account is created. Let's look at what are the components of the storage account. So we have blobs, we have file shares, we have queues, and we have tables. So let us go ahead and create a container inside the blob. Let's give it a name and click create. Now it is created. Now let us go ahead and upload a file inside the blob. Click on upload, and I'll upload an MP3 file, and here it goes, it's uploaded. Now this file is an unstructured file which we have placed in the container. Now the beauty of blob is you can download it from anywhere in the world. So you can open your storage account, you can go to the containers, you can go on to the container and you can download the file. That's the beauty of blob. Azure File Storage, your go-to solution for creating SMB file shares in cloud, just like on-prem. With Azure Files, you can create multiple levels of folders. Just like you do in your local file system, you can store file up to 1 TB on your file share, and it can be as large as 5 TB. The protocols it supports is SMB 2.1 and 3.x. With SMB 3.x, you get built-in encryption. There are two different performance tiers: standard file share backed by HDDs for general purpose or dev test environments. It's reliable, but it's slower. With premium file shares, it's backed by SSD. It's perfect for high I/O tasks like database or hosting a website. Access to your file shares is also flexible. Now you can use Entra ID, storage account keys, and shared access signatures for more controlled permissions. Now let's jump on into a demo where we will create Azure file shares in just a few clicks. Back to our storage account, we'll click on Files, File Share, and we will click on Add a File Share. We'll give it a name, Demo File Share, and click on Create. Now the file share is created. Now if you observe, if you click on Connect, it is going to give you a script which you can run for Windows, for Linux, and for Mac in order to connect to the file share. Azure VM Disks, where your OS and data disks are stored as .vhd inside Azure Storage account. Let's break it down. There are three types of disks in Azure. Operating system disks. These are SATA, Serial Advanced Technology Attachment drives on your VM that can be up to 2 TB in size. They contain the operating systems. Data disks. These provide persistent storage. It can go up to 32 TB. These are perfect for apps and databases, and they appear as small computer system interface SCSI drives on your VM. Temporary drives, labeled as D drive on Windows VM or /MNT/resource on Linux. These are non-persistent storage and store paging files. Now you should remember that it is important not to store any information on these drives. When the VM is corrupted, it's moved to another rack. All the data is lost in these drives. All of these together are stored in Azure Storage account, which is managed by Microsoft. One of the reasons you cannot access the storage account or see it on the portal. Now let's explore the difference between an image and a disk. An image is a generalized copy of an operating system which lets you create multiple virtual machines. Think of it as a template. A disk is a non-generalized OS or data disk attached to a VM, giving you direct access to its content. If you want to deploy an Azure VM, here are your deployment options. Deploy a VM using Azure Marketplace image, which is a pre-configured template from Azure's Marketplace, and it's ready to go. Custom images, these are generalized images which you can create yourself. For Windows, use sysprep for creating a custom image, and for Linux, use WA agent. And if you're deploying SAP systems, make sure to perform an instance rename with SWPM. Custom disks, perfect for moving on-premises systems to Azure while keeping your host names, SAP SID, and user accounts intact. Okay, now let's come back to our Terraform code and introduce two new concepts into it. Terraform output files. So what is a Terraform output? These are like reports which you generate from your Terraform code that tells you useful information about the resources you just created. For example, after deploying a VM or a resource group or a storage account, you might want to find out what is the ID of your newly created resources. Why is it important? You can share these details with other teams or scripts without needing to look them up manually. Outputs also come in handy for debugging, and it makes sure your infrastructure is set up correctly. Let's go back to the Terraform code and introduce outputs file. Okay, let's come back to our repository and let us add a file here, outputs.tf. We are going to add two outputs. So let us say output and give it a name. Resource group ID, and the value is Azure RM resource group AZ Certheads Labs RG dot ID, and we want to also output the VNet ID, so we'll say VNet ID, and the value is equal to Azure RM. We are going to refer back to virtual network resource which we had created, and we are going to find out the ID. It is going to output the resource group ID and the VNet ID. I'll save this file and I will say Terraform FMT, which is going to format the file. Pretty good. Next, let us introduce the concept of looping. So what's the deal with looping? Instead of repeating blocks of code for each Terraform subnet, Terraform allows you to loop through a list of subnets and create them automatically. This not only shortens your code, but also makes it easier to manage. What we will be using here is a for each loop, and we will be using a map object along with for each loop in order to make it effective. Why use looping? It saves time. No more copying pasting the subnet definition. Keeps your code clean and scalable, especially useful when you're dealing with large environments, and it's easier to update. Change one thing in your list and Terraform takes care of the rest. Let's come back to the code and introduce the for each loop and map object. Let us go ahead and look at our Terraform code. So what we want to essentially do here is we do not want to declare resource every time for creating a subnet. We want to loop this all these 4 subnets into one statement. So what we will do is, first we will comment. You can check out in Windows, probably it will be control backslash. So let us comment that, and also we need to modify the variables file. So whatever variables are there with regards to subnet, we will comment it out first. Pretty good. Now first we will write the variables. Now the variable in this case will be type map. So we'll say variable subnets type is map and any, and the default, which is basically the value, is subnet 1 is equal to, we'll give a map value which is the name of the subnet, which is equal to, which we will copy from here, the name of the subnet, which is this, and we will give it an address prefix which is equal to, we'll copy the address prefix of workload subnet, so this is how it should be. Now I'm going to add the subnet values for all the other subnets. Pretty good. So our variables file is ready now. Let us go back to the main.tf, and here we are going to now write resource. We are going to create subnet resource again. And the name we can just say subnet underscore certhead lab. And this is the important part, guys. For each, we'll say var dot subnets and go into the name value and loop each dot value, and the value you have to pick is equal to name. Same for address prefixes, each dot value, and the value which you have to pick up is address underscore prefixes. The next value which we need is the resource group name, so we will pick it up from our resource group which we have already created, dot name, and we need the VNet, the virtual network name, which we are going to pick up again from our virtual network resource which we have created, and we'll say name, and that should be it. We have to add a closing bracket, and that's it. Now let us go ahead and do a format. So you write Terraform fmt -recursive, and this is going to format the code, make it look good, and then we will perform a Terraform init. So Terraform has initialized successfully. Let's perform a Terraform plan to check if our configurations are correct. So as you can see, the configurations are correct, and we can now also see at the end it says changes to output, resource group ID and VNet ID. So it is going to output the resource group ID and the VNet ID after creating the resources. Let us do a Terraform apply with an auto approve flag. Meanwhile, I'll log into the Azure portal and check if Terraform has been able to apply it. So we are in our Azure portal, and I don't see the Certhead. Okay, it has come up now, and there is a VNet created. Let us see if Terraform has completed its tasks. It has applied, and you can see it has also given us an output, the resource group ID and the VNet ID. Okay friends, time for bonus content, question and answers. Let's go to the first question. You have an Azure subscription. The subscription contains a virtual machine named VM1 that runs SUSE Linux Enterprise Edition server and was created by using Azure Marketplace image. You plan to deploy 4 virtual machines based on VM1 that will have SAP Web Dispatcher role. You need to create a generalized image of the VM1. What should you do first? Your options are: install custom script extension, run sysprep, run WA agent, install Azure Linux VM agent. Now we have already read you should be using WA agent. So that's the correct answer. Let's go to the next question. An Azure storage account is capable of hosting different types of objects, including blobs, tables, queues, and files. What are Azure storage blobs? Unstructured files such as media content, virtual machine images, backups, or logs. Options are: blobs typically represent unstructured files such as media content, virtual machines, backups, or logs. Non-relational and partially structured content, which consists of multiple rows of data with different set of properties. Temporary storage account for messages that Azure services commonly use to asynchronously communicate with each other. So we know that the option should be A, because blobs represent unstructured files. Let's go to the next question. Which of the following performance tiers are offered by Azure Files? Basic Standard, Standard Premium, Basic Standard, and Premium. So we already have studied it's Standard and Premium. And that's the wrap, Certheads. Today we have explored fantastic world of Azure storage options, from blobs to files to elastic SANs and managed disks. I hope you found this information valuable for your cloud journey. If you enjoyed the video, please give it a thumbs up. Your support helps us create amazing content. Don't forget to subscribe and hit the bell icon so that you can never miss an update from Certheads. I'd love to hear from you. Share your thoughts in comments below. What are the storage solutions you're excited to try out? Let's keep the conversations going. Thanks for watching, and remember, cloud is your playground. Keep learning, keep growing, and we'll see you in the next video.